Hello everyone, it seems many people joined today. Nice to see you. Last time we talked about emails in Emacs and we used notmuch for doing it. Today we will continue this topic and we'll be talking about development workflows using mailing lists, and we'll compare it with more usual for many people pull request based Git workflows. We will be using Git, but actually it's not very coupled. Today's topic is not very coupled with Git. It will work with many other version control systems like Mercurial, Darks, or whatever uses patches. So the plan for today, we will talk a little about workflows. We'll discuss some technical details of it. We'll try to compare them. We'll make a small demo of mailing list development workflow, and we'll use capabilities of both notmuch and Git and combine them. And after that, we'll make a small conclusion, I hope. Okay, few terms that I will be using today. It's mailing list or discussion list. The difference is very small. Mailing list is usually something that you subscribe to and get messages with all other people who subscribed to this address. Someone just sent one message and it will be broadcasted to all the subscribers. And discussion list is basically the same, but anyone in this mailing list can send messages to it. Or for public discussion list or for public mailing list, everyone, even who are not subscribed to the mailing list, can reply or send messages to it. Cool. Hi, Dan. Forge. Forge is something is a website where you basically collaborate on some projects. GitHub, GitLab, Codeberg, SourceHut, and so on. But today I will be using Forge to describe mostly the websites which use pull requests and other GitHub-like stuff. And merge request is the same as pull request, is a special feature of such forges which used to get the changes from contributors. And I expect you to be familiar with Git and development in general, but I will try to describe all the details and introduce you to something you maybe not know yet, but I still expect that you are some kind of developer or any other type of contributor and familiar with technologies. And also I want to mention that it's my own opinion and it's something that I'm familiar with, and like it can differ with your opinion. And also I have experience with both workflows, and I even set up few teams to use GitHub based technology, and that is why I have some idea about how it works and have experience with it. So maybe I'm not so biased as you can see later. So a few properties that I will be using to measure the quality of workflow. High HD. First one is reliability. I expect that you can work even with partial connection or without connection at all, because it's very handy when you are in the trip or out of town, or your network connection is unstable. You can keep work on the stuff you want. And we know that Git is decentralized version control system, so why it shouldn't work? If we use Git, why our workflow can't work offline? It's not required by very cool feature to have, and many people prefer to work offline even if they have a good connection. For example, not to get notification and other attention and friendly stuff. So it's very good property, and it also includes that if workflow requires to trust you to or rely on some third-party organization or person or whatever, this workflow is not so good, because if a service or some organization decide to ban you on the server service, or your organization on this service, you won't be able to work without very without a lot of work of migrating from this service to another one, or you can even lost some changes that you did and which exist only on this third-party service, and so on. So reliability is important property, and I will be talking about it a few times during today's discussion of workflows. Attention friendly and concentration friendly is something that probably affects a lot of developers. When you work on some important code, you don't want to be distracted by notifications or other stuff. And here, even when you're using some website for reviewing some stuff, and it sends you a notification about new issues or new pull requests or something else, it's distracting, and I also treated it as attention unfriendly. And especially if you have to use chats to do your work, which is synchronous communication, it's also very unhealthy and can reduce your productivity as a developer. So it's also important property, I think. Number of repetitive actions. I will prefer not to do too much manual work. I would like to automate things and to make it easier. And yep, this property is more about automation and making you comfy in your development environment, and with not relying on third parties who decides how you have to work. For example, by providing you UI in a web browser, you will be a little more independent and flexible on your workflow. Privacy and security is also important. Not many people cares about it, but I don't want anyone to track me and gather data about me or share this data with some parties, some other organizations, or even if it's done unintentionally by leaking or something else, it's not very nice. And also, it will be good that people can trust our work, for example, by checking our signatures and so on. So the workflow should support it. Learning curve and step complexity is also important aspect, but it's at the bottom of the list because it's not really that much important for me, because I can contribute a few days or weeks getting my setup in a good shape, and if it is done only once, it's okay. And learning curve is almost the same. If I learned the tool and can use it, and nothing bothers me later, it's better if I can learn something very easily, but I will have a lot of manual work and a lot of problems with it. Better to spend some time at the beginning, but later be safe and comfortable with it. Good. It's some basic ideas which I will try to keep in mind discussing our workflows. And first one will be PR workflow, which is very usual for GitHub and GitLab and other stuff. and I will enumerate steps that are involved in this workflow, and will try to split them between one-time actions and many-time actions. And first of all, you need a mail account. Most of the people who some kind of developers already have email accounts on some server and can use it somehow. And also GPG key. It is necessary to sign your commits to prove that this commit is done by a person who owns the identity of this GPG key. And SSH key is necessary to push your changes to a forge. And for each forge, right now we are discussing the part of contributing some changes. So it's more for people who not owning the project, but who want to contribute to it. Actually, I didn't say at the beginning. I am a little more focused on free software and open source projects right now, so I will be discussing more slightly shifted to this area, but it will be applicable for even private and closed source projects as well, but maybe not in all details, but overall it should work for them too. And once per each forge, you need to set up account and generate password for it, save this password in your password store, set up SSH and GPG keys on this forge to make it able to push changes and sign and show the signature of your commit in near commit messages and so on. It's done for each forge, and it is important because nowadays GitHub is not the only one forge that exists, and many people migrating to GitLab, some to Codeberg, some people goes to SourceHut, and each time you need to register on some forge, it requires some time, and maybe if you don't use password managers, or in some other cases it requires some effort to create a new password and so on, to also confirm your email and maybe some other stuff. That is not very funny if you want to just contribute a few lines of code to the project on this forge and doesn't touch this forge at all after that. And once per project, you need to do few things. First of all, after you set your account, you need to fork this repository, clone it locally, and set up upstream remote. So you can pull the latest changes from the upstream, and if something changed on upstream, you can get those changes easily. After that, you set your local repository, you can start contributing. But before contributing, some people want to ensure that their contribution will be available, and they create issue or discussion or whatever it's called in the forge, and after that they have an ability to post the comments, and it will create a linear discussion, which is maybe not very flexible, but for some cases it works. Very simple, very straightforward. You have an issue and discussion for it and comments for it, and you can generate a good discussion on the topic. After that, you understood that your contributions will be available. You can do the following steps. Pull the latest changes from upstream repository. Now we have three repositories: your remote repository, the upstream repository, and your local repository. And originally you cloned your remote repository to your local, but now you need to pull changes from remote upstream repository. You create a branch for feature and commit the changes you've made. After that, you push those changes to your remote repository, and after that, you open a browser with the forge and create a pull request or merge request or whatever it's called. And after that, merge request is basically something that contains your commits of your branch and comments of people who reviewing your code. Also, in many cases, there are some CI checks that you have to pass, or your code have to pass, to make it clear that your code works properly. It's done automatically, so you just check in if tests are good, and that's all. Or if they fails, you just make another changes that will fix those tests. And also it will be good to link this pull request with the issue, with the original issue, to make it clear that something was already discussed on this topic and it's just a proposed changes to the issue created earlier. And it looks okay at the moment. Few additional steps, not so terrible, but let's take at the picture. This picture provides understanding of what is going on for the maintainer of the repository. Hi XX. Here we have a Forge, GitHub, for example, and few remote repositories, few forks for upstream repository. And each person who contribute have its own local repository and remote repository on the Forge servers. And when we will be getting those changes from contributors, we will need to do very interesting stuff as a contributor when doing review, but I will cover it a little later. Interacting with reviewer, you basically read the comments from reviewer or reviewers, and jumping back to your IDE, find the place in the code, fix it, go back to the web browser, paste the comment that you fixed it, and go back going to the next comment, finding this piece of code in your IDE, and so on. And after you addressed all the comments, you commit all those changes and push them to the branch. Interestingly, if you rebase the branch or address those comments in the pull request interface, those comments can disappear. And it sometimes it's removes the history, and it's not very clear why those changes were introduced, because the original comments are lost, which is not very cool sometimes when you try to understand what is going on with long living pull request. Okay, accepting contributions. As you saw in this picture, we have a lot of forks, and each fork can create pull requests, and it's easy to open a web browser and see the changes in the web UI and comment. But real review includes testing the code and also maybe changing it or playing with it somehow to make sure that it works. In perfect world, you have TDD, test-driven development, and person covered all the possible aspects of the code with tests, and they are executed on continuous integration service, and you see the results, and you don't need to check this code yourself. But even not very complicated changes in most cases should be applied first on your local repository. You need to use some jump to definition and debugger or other capabilities of your development environment to test and check that changes works as expected. And it is the point where we need to do an action. We need to add a remote for each contributor which sends pull requests to our repository. And we need to pull the changes from his remote repository and working on his branch. It's not very hard, but if you have 10 or 20 contributors, it can be quite time consuming to add everyone's remote and also to keep track of them. So sometimes not very nice experience. And reviewing changes, if you do it in the browser, in most cases it's not very forgot the word for this. You can miss a lot of things, and it's just a comments of obvious things that you found. But to make a real review, you need to pull those changes and to really test them by hands, evaluating some parts of the code and so on, using jump to definition, documentation, and all other features of your development environment. And when you're doing such a code review, you also need to write comments and jumping between IDE and web browser. And your web browser can contain some notifications and all other stuff. And it also have a UI which created by owners of the forgers. So it can be, for example, bright, and you have a dark theme in your ID, so you will be blinded when switching between two, and maybe some other not very cool things can happen because you will have to jump between two different environments created for different peoples and by different peoples. So not very integrated experience. You want to work in your IDE during your development work and not use some external applications. At least I want it, but maybe for some people it's okay to do it. Okay, you wrote all the comments and submitted them, and after that the contributor have to address those comments and to do some work. But if some other contributor wants to add his changes to address your comments, or if you want to do it yourself, it's not possible to push those changes to the branch of the fork repository because you don't own it. Probably in some forgers it allows to change and rebase and do some stuff with the branches of pull requests, but still not very cool, especially in some other forgers which doesn't support this feature, that other people want to contribute those changes, and especially not cool that the maintainer of the project can't introduce those changes himself instead of just commenting obvious things. And also it's much better when you're proposing the change in a way, hey, maybe we can do it this way, instead of saying you do it wrong, it should be something like this. And by typing comments, in most cases you say that something wrong with this line of code and you have to do it differently. But when you have ability to add your changes on top of it, you just introduce your changes and explain why you're doing it, which is much nicer in many cases when you're doing code review. Cool. It's very nice that GitHub introduced this feature, but for example, GitLab or Codeberg or some other forge that people use can miss this feature. And actually, it's interesting that many forges re-implement the features that's already available for Git. Okay, and as you can see that the process already quite complex and requires a lot of actions. and we didn't even discuss some advanced Git flows that can really complicate all the things. And now let's take a look at mailing list workflow. For people who are not familiar with mailing list workflows, it's actually the original approach that was used for Git. Git was developed by Linus Torvalds and some other people for managing source code for Linux kernel. And they do the development of Linux kernel in mailing lists. And Linux kernel, one of the biggest software project nowadays, and it works perfectly fine with mailing lists. And actually, Git integrates with it very naturally. Before contributing, you obviously need a mail account on some mail server. It can be your server or someone else, but you need it anyway. Also, it's cool to have GPG because you want to sign your work to prove that it's done by you. And you need to set up a mail client. It may be tricky because using webmail for developing is not very pleasant experience. I tried it and it's really not so cool. For many reasons. Many mail clients doesn't support trading, especially web mail clients, and also they try to introduce some HTML parts to it, which will mess everything, and the maintainer of the project won't be happy. But after you set it up, you will be quite good because you don't need to change anything. If it was set up once, it works almost forever. Hi, Israel. Nice comment about using YouTube instead of something more false. Actually, there are few reasons. First of all, YouTube has a lot of features for creators, so I can see some analytics, I can add captions or time codes and so on, which is handy. Also, everyone who want to watch my videos or streams can use MPV or I don't remember the name of the project. InVideos. InVideos is alternative open frontend for YouTube, and you as a client can use it without using proprietary JavaScript and so on. So from the watcher point of view, you're not forced to use proprietary or tracking software. As a creator, I use it because it's a little more simpler to start with, and later I plan to make streams both on YouTube and PeerTube or something more forcey, and maybe later I will migrate it with all the auditory I have. So yeah, it's kind of strange, but it is what it is. Good. We set up our mail client, and once per mailing list, we need to add this list to synchronization tool to get all the messages of this mailing list, to be able to search them and do other stuff like replying to them or referencing them. It's very basic operation, and in most cases it's just a few lines of code. After that, you can start work. You create thread, you discuss a feature that you want, you reply to the thread with patches, or you just reply to subthreads with some discussions. And actually work already started. And that's all. You don't need to register anywhere, you don't need to do anything special. You just take your commit that you did during development of the feature. Obviously, I forgot to say that once per project, one second, once per project. Clone the repository. You need to clone the repository of the project, but after you cloned it and download it, actually it's not necessary step, but very handy if you work on the project for some time, and it's optional, actually optional. After you clone the project, you can already start work on it by just sending patches using your email. And you can see it's much simpler process than the one here. Much less steps. Much more less steps. And from the maintainer point of view, I just have already everything set up and running, and I just following some threads, take patches from them, apply them, test them or work on some additions for them, and reply to the thread. The discussion, their development, and everything else happens in one place. When you finished with this patch set, you can just stop posting to the thread. We will discuss some problems of mailing list workflow, but before it, let's try to compare pull request based and mailing list based workflows. Most important part is in development is communication. Obviously, you need to share your changes with other developers. You need to review changes of other developers and to discuss those changes, tasks, and other stuff. Actually, if you have any questions, type them in the chat and I will try to reply them. Let's start from review. Review is something that you can do on your own. You just take the changes proposed and apply them to your local repository, test them, play with them, maybe introduce some other changes or make some other additions. And it's very handy to do it with your IDE. You have all your developer tools ready, and with mailing list workflow, it's actually how you do the review. You just take the patches and apply them to your local repository and work with them with your basic development setup. And it's very convenient. And if you need to do review and reply to someone, you just reply to the message on the right window and your ID on the left window, and you just make some changes or find some problem and reply to the message instantly. And I will demonstrate it a little later, the process of review. You can use custom patch format. It's something that helps everyone to see the change the same way. In forges, in most cases, you can see the difference between two commits, and you can only expand the region that is covered by this view, and probably remove white space changes by special query parameters to the URL. Custom patch format allows to be aware of code structure. For example, there are structural diffs which makes diffs based on language semantic, which helps to make them not only more human readable, but also highlight exact changes that was done. Because some patch algorithms can make some strange patches which doesn't reflect the actual change. For example, if you move some Lisp expression from one function to another, in structural diff, you will see that this function was moved but in non-structural diff it can be some magic with deleted liners that doesn't respect the semantic of the language, underlying language. That is why custom patch format is advanced by sometimes very useful feature. Every communication happens in threads, and it's the one thread for one feature in most cases, and threads very flexible mechanism that allows to discuss different sub-problems in one place. With forgers you have issues, pull requests, discussions, inline review comments, and so on, and everything is quite diverse, and you can seek for some information in different parts. And also everything of that work with a stable network connection. If there are some problems on your forge, or you have some network issues or something else happens, you won't be able to work, and all your teammates too. With emails you can have all the copies of all emails locally and work on them. And here you can see few threads, and you can see that different people involved in it. Someone propose a patch, someone replies to the patch, just taking the original message and inserting their comments inside it. So you can discuss the code, comment the code, and review the code in the same place. So you don't have to jump between different applications and tabs and so on to get your work done, which is very cool in terms of user experience and also very attention friendly. And when you decided that you wanted to reduce more changes, or as a person, actually it is a very cool example. I will come back to it later. Yeah, I will come back to it later. One more time, complete thread, which is much more flexible than diverse linear discussion with disappearing comments. It's very good and useful in terms of proper communication, I think. Actually, it's not much, and it do it automatically. You can control the behavior of collapse, but it's a default behavior. I didn't set something for that. I already covered all those three items. Durable discussion, that means that everyone who mirroring a mailing list has a copy of all the discussions and can work on them offline, and it's decentralized in the same way as it's done for Git. Actually, I use public inbox, which allows to clone the mailing list using Git, and I don't even subscribe to mailing list. I just clone them and update using a special tool which just clones the repository and delivers the messages from this repository to my mail directory. You can, as a third developer, to interact with changes that started by one person. For example, someone started to work on some changes. Here, Christopher provided a patch, and this patch introduced some changes, very important changes. And Ludovic responds, do some comments, and Christopher also replies to it. Ludovic adds something, and Christopher say something else. After that, it was a big delay. You can see April 14 and July 3rd, the thread was inactive. But it was really important change, and Breeze decided to pick up the work done by Christopher and to provide a new patch set based on the work of Christopher, which addresses all the issues discussed earlier here. So Breeze sends 3 more patches. Oops. And those patches address all the issues that was discussed earlier. After that, Chris comes, adds some comments about those patches, and Breeze provides new set of patches, which also addressed Chris' comments. And after that, Chris says that everything is okay, it can be merged. You can see that Christopher started the work, discussed something with Ludovic, and after that, for some reason, maybe he was busy or something else, he didn't update this thread for some time, and some other person picked his work and continued it, which is cool for some open source projects, and it's even cool for any other project, because some person can go to the other organization or to Bill or something else, and someone else can pick up his work and continue it, which is cool, I think. Good. Another thing that can be done with mailing threads. You can see that every message contains few headers. And threading is done by, actually it's a plain view of the message. I need it because I want to show you in reply to header. A message has in reply to header, and based on this message, actually it contains some message ID. Every message have a message ID, and some messages has in reply to header, and this allows to build this threaded structure of mails. But also you have two NCC headers. Two is a recipient, and CC is also recipient, but those recipient doesn't have to act on this message. It's just a copy for them. You can see that Ludovic replies to Christopher, and also CC to debugs. It allows for all subscribers of the mailing list to get this message, but the primary recipient is Christopher. And here, if you remove CC header, it will be sent only to Christopher, which will make it private message. So inside a public discussion, you can keep the threading the same, but make the messages private. It's very useful in case you want to send a cool meme or a funny picture of your cat to your coworker, which is very related to this thread, but don't want to share it with someone else. Very useful use case. Actually, it can be a different real world use case, but just to make you know what is possible with emails and threading in emails. CI. In some forges there is a built-in CI. In some forges it's possible to add it using webhooks and so on. And every pull request sent to a repository can have some checks, which will be automatically launched. In mailing list, by default, there is no CI, and it is for a few reasons. First one, it's relatively hard to understand how to apply all the patches mentioned in the thread. and to make them work, because someone can reply with some suggestion which maybe not even tested. He just says, oh, maybe we can do something like that, and write some patch that maybe not working at all. And also it may be just a suggestion and doesn't have to be applied in the proper order, or doesn't have to be applied at all. So it's not very easy task to understand how to take all the patches from the thread, apply them on some branch, and to run tests. So in most cases it is expected that user will pick necessary patches and will test this code themselves. Which is not necessarily bad. How does SourceHut do CI with mailing list? Okay, I will cover it a little later. Just wait a second, or maybe a few minutes. As I said, it's not easy to take all the patches from the thread and apply them in proper order and do it automatically. So in most cases, it's not done automatically in mailing lists. It is because mailing lists are very flexible and it's really a hard task to do it automatically. But as I said, it is expected that everyone will be picking all necessary patches himself and test them locally. It's actually a very good property of the software if you can set up all the testing the testing environment locally and do it, and which encourages every contributor to test it locally. In some cases it's not possible, but in most projects, if it's not possible to test it locally, that means that your project smells and you need to work on the testing approaches for them. So there is a question: is it really important to have CI for mailing list? Because you can have CI for the central repository of the project, but maybe it's not so important to have every patch tested on the mailing list, because everyone who will be participating in the thread can test it themselves, which is actually also good for the property I mentioned here, for reliability, because it doesn't depend on any central service for continuous integration. Everyone can work locally and can test locally. And after the maintainer decides that this set of patches is good enough and applies to the branch in the central repository, those changes can be executed against some environment on continuous integration server. So maybe it's not necessary for mailing list, but there are some solutions that we discuss in a few minutes. Okay, I already talked about offline work. I will elaborate a little more on it. You can just trust someone saying they tested. Yes, you can't, but you can do it yourself. If you're a maintainer and take some changes from someone, just taking the patches from mailing list, applying them, you can run all the tests locally on your machine, and before merging, you test it, and if tests passes, you merge it to the remote repository. And also on the remote repository, it's not necessary to merge them into master branch. You can merge them to staging branch or to a feature branch, and after the CI passes, this branch will be merged to the master or something else. It's very flexible and configurable and depends on the project. Yeah, another option is using a separate branch for initial merging of the changes. But as I said, it's very good when your project works locally and you can run tests locally, and it's really shines when you work offline, because uh, if you can't run tests locally, you can't work without network connection and access to testing environment on some CI server. And also it means that the developer or contributor won't be testing, because it's not very easy without access to CI server or without access to the network. It means that it will be tested only in the very last moment, because it's not easy to test it locally, which is not very good in most cases. Okay, continue the topic of offline work. You can take and mirror the whole mailing list to your local machine, and you will get all the discussions happened about this project during the start of the project, which very useful to find known issues, some solutions, or maybe previous discussions, or maybe even some snippets of codes that was proposed by but not merged, and many other useful stuff. And everything of that will be available to you, even if you don't have network connection, because everything is on your local machine. Using some good mail clients like notmuch, you have a full text search, because your emails are indexed, and you can operate on them locally with very powerful tools. You can tag your emails, search your emails, filter, and automate your workflow as you want. Also, you can take the patches from threads or subthreads and apply them in one click or in few keystrokes. And obviously, you don't depend on the connection, because even if the mail server or mailing list server is down, if the remote repository is down or something else happens, when you send email, you have not only to header but also CC header, and this email can be delivered to the other developer, even if the server which hosts your mailing list is down. And later the client will retry to send, and it will be delivered to mailing list. But before that, the other developer who also works on this project will get your emails without having access to the mailing list, which is very reliable and cool. But maybe not so actual nowadays, because networks are better and uptimes of the servers are also better, but still valuable. Okay, I tried to compare most important things. It's communication, testing, and continuous integration, and offline work. You can do any offline work with you can do some offline work with your Forge, but you can do review or discussions, or search at least search the discussions when you're offline. I will show you how you can prepare review, search discussions offline in a few minutes. Yep, maybe I'm missing something, but I think the communication is most important part of comparison, and CI testing and offline work is also important. And something else maybe I missed, but it seems not so important for me. Good. Any questions so far? Okay, I can show you the threading a little. Here you can see that there was some patches proposed, and people replied to them, and after that the second series of patches were done, and actually each commit is a separate patch, and each patch is a separate mail message. And originally those two replies was not here. There was one message and four more messages for each commits. And after that, when all those patches were sent to the thread, some person replied to one of those commits, which probably contains some information about possible improvements for this commit. And I will show it in a practice just in a minute. But let's first cover some problems that I see my linked list can have. Too much flexibility. It's a very well engineered technology, but it's very flexible, and if we do not provide a good interface for it, it can be confusing and error prone. Probably it's a correct word. That makes it easier to make a lot of mistakes, replying to the thread or setting the wrong headers or attaching the patch in the wrong way and so on. So the flexibility on one hand is very cool. On the other hand, it complicates things, especially for newcomers. But even experienced people have more possibilities to fail in some cases. CI, as I said, maybe it's not necessary to have CIs for mailing lists and have them only for actual repositories and branches on those repositories. If you have a good local testing setup, it is probably true. But also, for example, a Forge, which is different from GitHub because it's using mailing list workflow, provides the ability to set up continuous integration for mailing lists. And inside your mailing list, you will see the tests that went correctly and the tests that failed. It takes all the patches from the thread, which contains a special prefix inside subject, and apply them and run CI jobs. It's one way to solve this issue, but maybe for some projects it won't work. But at least there are already some solutions for it. Okay. So CI, there is no default option for CI or default approach for CI for mailing lists, but it's obviously possible to solve with a good style guide on how to compose your messages, and maybe some tooling which helps to compose them, and automation will be easy. Unfamiliarity for many newcomers and even for experienced developers who are not very familiar with underlying of emails, it can be quite confusing how to properly use emails. And because a good email client is not very popular and many people use web interfaces these days, which doesn't support threading and all other very cool capabilities of emails, it increases the learning curve. Everyone uses emails, but not so many people use them good enough. So they have to learn how to use emails and mail clients. And a good contribution guidelines, and actually a good established guideline which works across many projects will be very cool, but there, at least as far as I know, there is no some good uh, guideline which applies to many projects which based on mailing lists. So it will be cool to have one. And another one is a problem of setup. It's not easy sometimes to set up mailing client in a proper way. But here the solution may be a reproducible development environment. So someone defines how your email client should be configured, and you just use this configuration. And because it's completely reproducible, it's just very easy to use. Spam is another problem, and there are a few solutions like closing mailing list only for subscribers or doing some advanced techniques. I didn't get any spam yet in any development mailing list, even in public development mailing lists yet, but I hear that some people mention it sometimes. So I'm not sure how real this issue is, but good to mention and make you aware. Comprehensive list of issues. It's something that also already solved by, for example, SourceHut, a forge which uses mailing lists, or for some other tools, for example, debugs and many other, which collects your emails from mailing list and creates for each email a separate bug, which can be after that closed or changed or merged with other threads or with other bugs and controlled in some way. So you can take a web interface and see all the actual issues which are not treated yet. XX says that he saw spam in some GNU mailing lists. Yeah, it's maybe possible, but I didn't, at least yet. So it's partially solved. The another approach is not to use a separate web interface, but to store issues inside Git repository itself. It's also maybe quite tricky to set up, but another solution. Joining to mailing list later, because if you join to mailing list right now to the project which is in active development, you will get some messages that are not attached to some other messages which have in reply to header, but to the message ID you don't have in your mail inbox. That it is because you don't get the archive of the mailing list. That is why I prefer to fetch the whole archive of mailing list using public inbox and have all the messages from the beginning of the project. So it's solvable and solvable very easily for most cases for mailing lists which have public inbox mirrors. And social proof and distribution of your projects. Many people relies on GitHub stars or some other criteria when picking the library and so on. So if your project are on some separate forge which doesn't have GitHub stars, it can be harmful for the spreading your project or promoting your project in some social groups. But it's not a problem of mailing a list workflow itself. It's more a problem of distributing software and promoting software. So you can mirror it on GitHub to have the stars placed by people who use GitHub. or you can just keep it only on your server and not promote it at all. So it's not about mailing list workflow, more about promoting your software. And a small demo. I will show you how mailing list workflow looks like, and we will finish our stream after it in a minute. Good. Here I have a thread which I created a week ago, and here I sent 4 patches. I sent a first message which introduces the changes that we've done, and after that I have a first patch. As you can see, it's inlined in my message, but if I want to see it as a div, I can call a special function and we'll see it as a div. Good, and a few more patches here. And this whole patch set contains 4 patches. And I already removed these patches from my local repository and they exist only on mailing list. Also, Maxime replied to my changes and provided some insights. And after that, after he said that this construction is not very cool to use because it's some kind of hack, I addressed his comment with another patch here and changed this construction to a better one. You can see the patch here. And let's assume that I'm reviewer of this patch set. And when I will be playing reviewer, I will place a hat on my head. Okay, I see the messages from some guy and see a patch set of 4 patches, and I want to apply them. First of all, I check that I am not on the project. Let's cd to the project directory. Currently, I'm in the directory of my local Geeks repository, and you can see here the Git status of my Git repository. I am on the master branch, which is behind origin master by 200 commits. I will fetch the changes without merging them. 229. And I will create new branch out of origin master, which is a latest commit on the master, and I will call it geeks home tmp, because I know that those commits are related to geeks home tmp branch. Cool. Now I have a separate branch and I can work on it, but you can see that there are some untracked files. I want to get rid of them. I will stash them, so later I can get those files back, but for now they won't be interfering with my new changes. So I have a very clean branch without any changes on it, which is equal to origin master. Now I can review the content of the patch by opening it, but when I understood that those patches are good and I want to test them, I will pipe the message to some other command. In this case, I will use git am command, which applies the patch. Because the message itself is a patch, I will just pipe the whole message to this command. And I do it with a vertical bar hotkey, which is not much show pipe message command if you're interested. And here I see that new commit appeared on this branch. Okay, I can do the same for the second message, and one new comment appeared here. Obviously, I do it manually for each for each message right now, but it's very easy to implement the code that will take all the patches that, for example, I marked in some way and apply them. Now you see that all 4 patches applied and 4 commits appeared in my local Git repository. Also, I know that this thread contains an addition to those 4 commits, and this addition is done in a patch which is attached to the message. This patch attached as a file. And I can type dot and vertical bar. Wow, nice. I don't know why it happens. For some reason. Okay. It will pipe this attachment to the command. For example, to git am2. And now I will have 5 commits applied on top of the last commit of origin master branch. And I know that this is temporary patch, which is just a suggestion. But and I don't want it to be a part of my commit history. But it solves some issue. I can do a soft reset, which will remove the comment from the list, but will keep all the changes introduced by this commit. And I know that this part of the commit is related to first commit, and the second part is related to the second commit of patch set. And let's make a temporary commit which contains part of those changes. Fix tmp1. And second temporary commit. And now I have the following commit history. The 4 changes proposed originally and fixes to first commit and to the second commit. Now I need to squash or merge those commits with the related commits they are fixed. For that I will be using interactive rebasing and will squash the first fix with the first commit and the second fix with the second commit. After that, I got 4 new commits, which has the changes that was introduced later in the thread, which was proposed later in the thread. And now, what I want, I tested, they works pretty well, and I want to send this updated patch set to an original thread. 3 dots in a thread view probably means that something collapsed, I suppose. Why don't you use cf/s? What do you mean? cf because the fix up will merge the commit with the latest one, or maybe not. Anyway, it's handy to use interactive rebasing because you can do a few different changes at once and rewrite your commit history. But maybe I will check those separate hotkeys for special functions later. Thank you. Okay, I will take a look at the subject later and we'll see which 3 dots you are talking about. We introduced the updates to our patch set, and now we need to create a list of new messages that contains this patch set. I will mark all the commits I want to create patches from, and we'll type W for format patches, W, C, create patches. I want to have a cover letter, Ctrl M L, and I want it have reroll count. That means that it is the second version of patch set, and create patch set. It will ask for subject. Here in the subject I will place the same subject I have in the thread. Which thread I used? This one. I will use the same stuff, cover letter, and here we changed to A. Some description of what changed since version 1. Cool. I created a cover letter, and all the patches are available here. Good. Now I need to send those patches. I can do it in different ways, but I will send them manually. For that, I will open a thread. And I need to reply to this message. I will reply to it, so it will show me necessary headers. I need in reply to FCC and 2 headers. Good. I will copy it and we'll go back to my Magit interface, open cover letter, and I will add here few more lines. So not much message mode. So my patch right now is a complete message that I can send to the mailing list. Actually, it can be done automatically, but here I show you that it's very simple underlying technology, just a plain file with key value list and plain text content. Yep, let's just send it. And let's check that it appeared in our thread. You can see here 2 minutes ago appeared a new message in the thread. Magit never directly interacts with the mailing list. We must produce patches manually. Actually, Magit doesn't interact with mailing list. Yep, but we don't have to produce patches manually. We can use other packages for it, and probably some functionality can appear in Magit too. I don't know, but I'm sure that there are already some packages that allow us to create patches automatically. I just do it manually to demonstrate the whole process that can be automated really easily with Emacs and maybe a few other tools. Okay, I sent a cover letter which contains the information what changed from first patch set, and now I need to reply to this message. Actually, it can be done very automatically by some script or some package. I just do it to show you the process which will happen under the hood of this tool. Oh, that's a very good question. Three dots mean that the header, the subject of the message is just re and the subject of the previous message. You can see that it means reply to the message above. It is done to make it to make UI more lightweight and not too noisy, because it not provides any additional information. It just replies to the previous subject. So instead of showing the re semicolon or colon the previous subject, it just shows three dots. Good, I just started a demo and already made some stuff that you can watch later. And we almost done with sending new patch set. We copied necessary headers and we'll open some patch. We'll add those headers. We prepared a new message, and this message replies to our cover letter, and we can send it. And we go back to our thread and see that this patch replies to the cover letter. It is done to group those patches under some cover letter which describes the content of all those patches. So the other patches should reply to the same message. That is why I copied previously used headers and also send it. And let's do the same for all other patches. Good. We sent all our messages, and you see that we have a subthread which is a cover letter and a patch series under it. This message is not sent, it's a draft. I don't know why it appeared here. Probably I tried to edit this message and it created a draft, but it doesn't send. Actually, all those messages are not sent to the mailing list too, because I don't actually send them, but I queue them on my local machine and can send them later. And I have MSMTP queue. And here you see those messages are in queue but not sent yet. So I will remove them later, not to bother other people with those messages that I prepared. Or maybe I just send them in the way they are created, because it's actually solves the issues, and I really need to send a second version of patch set. Good. I was a reviewer which took the code, tested it, introduced the changes proposed by the other person, and created a second patch set. And now I'm another person who saw for example, I'm original patch after of this patch set. I can see what changes were introduced and reply to those changes. For example, here I can see that the reviewer changed double @ sign to @ sign right here, for example. And I'm very excited that he fixed it himself. And oops, very cool that you fixed it. Thank you very much. And here you can see some replies to one of his patches. How many reviews? Oh, actually, it's a tough question. I need to write a guideline about wearing hats for reviewers. I think that's mostly all I wanted to show you about mailing list workflow. To recap what we've done, we had a patch set proposed by one person. We had a changes proposed to this patch set. We had a patch by a third person who actually introduced those changes here. The reviewer took the original patch set, took the proposed changes from another person, and combined them using rebase and sent a new version of patch set with all the necessary updates. And the first person who introduced original patch set replied to one of the commit messages with his comments, and now the maintainer can merge these patches if he wants. So it's not necessary even the original reviewer who will merge those changes. It can be another person. Yep, showed a lot of features that is possible with mailing list workflows and mostly impossible with Forge oriented, OPR oriented workflows. And everything that I've done here was completely offline. I didn't send a byte over the network during the whole demo. Any questions? Actually, if you want to ask questions later, you can find me on Mastodon. It's Mastodon instance, or send them by email. Let's make a small conclusion. There are some problems. Obviously, it's not very easy to set up, and from both sides, from contributor side and from maintainer side. But it's not a blocker. Many projects use mailing lists, and obviously there are some good solutions that will appear soon, which will reduce the barrier and learning curve and will make it much more easier to use mailing list workflows. Mailing list provides much more integrated experience. You don't have to use some web services or something outside of your IDE. You can do both mailing, reviewing, and interacting with your code in one place, which is very cool. It's privacy and attention friendly. You don't have notifications, you don't have any trackers, and you doesn't depend on any third parties, which gives us reliability. And also the federated nature of emails makes it possible to do all the stuff offline and not depend on some central server, peers or contributors or developers of the project can interact directly without using any central server, because emails are federated and Git is federated. And why not utilize those capabilities to get a cool and very strong reliability? It's flexible, which is a good side and a bad side at the same moment, but it allows to make a very nice automation and to adjust it to your workflow and to the workflow of your organization or the project, and get a really comfortable environment for development. That's all for today. Thank you for your attention. I hope you enjoyed the stream. See you.